Hello dear students, this is me Bharti Kharat and today again we are going to continue with Pythagoras Theorem. Okay, in the last video we have studied practice set 2.1. Okay, we have also studied that in Pythagoras Theorem the relation between the hypotenuse and the sides making a right angle, that is the relation between the opposite side to the right angle and the remaining two sides is given. Okay, today we will study in a triangle the relation between the sides opposite to an acute angle and the remaining two sides. Okay, as well as we'll also study the relation of the sides opposite to the obtuse angle with the remaining two sides. Okay, this can be also determined with the help of the Pythagoras theorem, and then using the acute angle theorem and the obtuse angle theorem we are going to learn a new theorem, that is Apollonius theorem. Okay, Apollonius theorem. Okay, now children, if you see your textbook, in your textbook this acute angle theorem as well as this obtuse angle theorem is given in the form of a solved example. But children, if you understand this example very properly, it will be very easy for you all to grasp the Apollonius theorem. Now without wasting a much more time, let us start with the acute angle theorem. Okay. Okay, now see, in this first example, that is an acute angle theorem, you can call it as they have given triangle ABC. Okay, they have given triangle ABC. Okay, and angle C, you can see this angle C is the acute angle. Okay, angle C is the acute angle, and segment AD, you can see this AD is perpendicular on BC. Okay, then we have to prove that the side opposite to acute angle, that means AB square is equal to the base square, that is BC square, then plus the adjoining side to the base, that is AC square, minus twice BC into DC. Okay, this we have to prove. So it is very easy. First of all, we'll write down the given things. Okay, so let us write down what is given. Given it is given in the figure that it is given in the figure in triangle ABC. Okay, in triangle ABC, AC, therefore in triangle ABC, AC is equal to, okay, you can see AC. Okay, AC is equal to B, then AB is equal to C. Okay, then AD, okay, AD is equal to P. Then if you see this BD, they have given, I forgot to write here, that is A minus X. Okay, BD is equal to A minus X. BD is equal to A minus X. DC is X. DC is equal to X. Okay. Now children, they have also given here that angle C. Okay, you can see this angle C is an acute angle. Okay, angle C is acute angle. Now they have also given here that is AD is perpendicular on BC. AD is perpendicular on BC. So these things are given. Now to prove we have to prove that AB square, you can see this side opposite to acute angle, that is AB square, I'll write it down here. Okay, AB square is equal to the base square, that is BC square, plus the side adjoining to the base, that is AC square, minus twice BC into DC. Now children, if you carefully observe this diagram, okay, that is BD is A minus X and DC is only X. That means this entire BC is A. Got it? BC is A. So we'll write down here BC is A. BC is equal to A. Now let us move on towards the solution. Okay? Or we can call it as proof. Okay? Proof. Now in triangle ADB. Now first we'll consider this half right angle triangle. You can see this right angle triangle, that is ADB, where angle D is 90 degree. Okay, so as we are going to apply here Pythagoras theorem, for that we have to consider this right angle triangle. You can see this side. Okay, in triangle ADB, now we will apply here this Pythagoras theorem, that is hypotenuse square, that is AB square is equal to AD square plus BD square. Okay, now write down here by Pythagoras theorem. Okay, now if you see what is AB square, that is C square, AD square is P square plus BD square is A minus X bracket square. Okay, therefore C square is equal to P square plus A square minus 2AX plus X square. Okay, now this C square is equal to A square minus 2AX plus X square plus P square. Okay children, now if you see in your textbook, they have given this acute angle theorem in the form of fill in the blanks. Okay, I think so here they have given to fill, so you have to put there P square. Okay, we'll put here as equation 1. Okay, now let us consider in triangle, the other triangle we'll consider, that is ADC. Okay, now in triangle ADC, okay, now here also we'll put the Pythagoras theorem, that is AC square is equal to AD square plus DC square. Okay, now you can write down here again by Pythagoras theorem. Now how much is AC? That is B square is equal to AD is again P square plus DC is X square. Okay, now see, this X is also asked for your fill in the blanks in the textbook. Okay, then B square minus, now we'll take this X this side, X square is equal to P square, or you can also write it down as P square is equal to B square minus X square. Okay, put this as equation 2. Okay, this is also again for fill in the blanks. Now if you put the value of P in equation 1, now we'll write down here, putting the value of P in equation 1. So what is equation 1? That is C square is equal to A square minus 2AX plus X square plus now P square. So what is the value of P square? That is B square minus X square. Now children, if you see here, this plus X and this minus X will get cancelled. Again you will have C square is equal to A square minus 2AX plus B square. Okay, now if you see what is C square, that is AB square. So we'll write down here AB square is equal to, now what is A square? A square is this total BC. Okay, A square is this total BC. So we'll write down here BC square, then minus twice Now twice a means what? Again BC into x. What is x? DC plus b square is AC. AC square. Now we'll arrange it properly and we'll get our desired solution, what we have to prove. Okay, therefore I'll write down here AB square is equal to BC square plus AC square minus twice BC into DC, and this is your proof, or this is your solution. Okay, it's very easy. The side opposite to the acute angle is equal to the hypotenuse square. Okay, you can call it AB square is equal to BC square plus AC square into twice BC and into DC. Now let us move on towards the obtuse angle theorem. Okay. Now for this, in triangle ABC, now you can see in triangle ABC, now this triangle, angle ABC, angle C is obtuse angle. Okay, that means its measurement is more than 90 degree. If you see this AD is perpendicular on BC. Okay, AD is perpendicular on BC, and you have to prove that AB square. Okay, AB square is equal to BC square plus AC square plus twice BC into DC. Okay, now let us move on towards the solution. Okay, now in triangle ABC, now you can see ABC, it is given by figure, it is given by figure that AD is equal to P, AD is equal to P, AB is equal to C, BC is equal to A, AC, you can see this AC is equal to B, I forgot to write it down, that is B. Okay, AC is equal to B, CD is equal to X, and BD is equal to, now if you see this entire distance, BD is X plus A. Okay, BD is equal to X plus A. Now children, let us consider in triangle ADB, this big triangle. Okay, let us consider this big triangle. Therefore, in triangle ADB, angle D, you can see this angle D is 90 degree. Now by Pythagoras theorem, if you put Pythagoras theorem to this big triangle, that is hypotenuse square, that is AB square is equal to, that is BD square plus AD square, or AD square plus BD square, AD square plus BD square. Okay, now what is AB? That is C square. AD, that is P square plus BD, you can see this BD, that is X plus A square, X plus A bracket square. Therefore you can write down here C square is equal to P square plus X square plus twice AX plus A square. Okay, now children, we'll write it in this way. C square is equal to X square plus 2AX plus A square plus P square. Put it as equation 1. Now let us consider the other triangle. Therefore, in triangle, now the smaller one, ADC. Okay, in triangle ADC, angle D again is 90 degrees. Okay, therefore again by the Pythagoras theorem, I am writing it in short form. You may write it in full form. Okay, Pythagoras theorem. Now if you see here, hypotenuse is this, that is AC square is equal to AD square plus DC square. Okay, therefore AC square, how much is AC? Sorry, AC square is P square is equal to, now AD, how much is AD? Sorry. AC square, AC square is B square. B square is equal to AD. AD is how much? P square plus DC is X square. Okay, now what we'll do, we'll shift this X to the other side. Therefore, B square minus X square is equal to P square. We'll write it down it in a correct form, that is P square is equal to B square minus X square. Okay, so here we have got the value of P. We'll put it as equation 2. Now, similarly as we did in the acute angle theorem, we are going to put the value of P in equation 1. So write it down. Putting the value of P in equation 1. Okay, so what is equation 1? C square is equal to X square plus 2AX plus A square. Now instead of this P, we'll put the value of P, that is plus B square minus X square. Now this plus X square and minus X square will get cancelled, and C square is equal to A square plus 2AX plus B square. Okay, I've arranged it in a proper form. Okay, now what is C square? If you see, this C square is AB square is equal to A square, that is BC square plus, now 2, A is how much? BC into X is CD plus B is AC square. Okay, therefore you can write down here AB square is equal to BC square plus AC square plus 2 into BC into CD. See, CD or DC, one and the same thing, hence it is proved. Okay, now using this acute angle theorem and obtuse angle theorem, we are going to study the Apollonius theorem. Okay, now children, they have given here the Apollonius theorem. For that, they have given a triangle ABC, okay, and they have said that M is the midpoint of B. Okay, M is the midpoint of BC. Okay, M is the midpoint of BC. Then we have to prove that AB square plus AC square is equal to twice AM square plus BM square. Okay, so for that, first we'll write down what is given. Okay, now in triangle ABC, okay, what they've given, M is the midpoint, M is the midpoint of BC. Okay, now as M is the midpoint, that means BM is equal to CM. Therefore you can write down here BM is equal to CM. Okay, now what we have to prove? We have to prove that AB square plus AC square, AB square plus AC square is equal to twice AM square, twice AM square plus twice BM square plus twice BM square. Okay, now children, for construction, they have not given this AD. AD is not a part of triangle. We have constructed it. Okay, therefore write down there construction AD perpendicular to BC. Okay, now let us consider triangle ABC. Now let us consider triangle ABC. Now in triangle ABC, AM is not perpendicular to BC. Then out of angle AMC and angle AMC and AMB, one angle is acute angle and other will be the obtuse angle. Okay, when we consider if this AM is not a perpendicular, then what is going to happen? Angle AMC and angle AMB, either one will be the acute angle and other one will be the obtuse angle. And AMB, one angle will be acute angle and other will be obtuse angle. Okay, now if you see in figure angle AMC, okay, you can see its measurement is less than 90 degree. That means in figure angle AMC is acute angle and angle AMB, it is more than 90 degree. This angle is obtuse angle. Okay, now let us consider in triangle AMC. Let us consider this triangle. In triangle AMC, angle AMC is acute angle. Okay, now by putting the acute angle theorem, what you will come to know? AC square, I'll write down here, AC square is equal to CM square plus AM square minus twice CM into DM. Okay, now put it as equation 1 and you can write down here from application of Pythagoras theorem. Okay, from application of Pythagoras theorem. Okay, now let us consider triangle AMB. Okay, therefore in triangle AMB, okay, angle AMB is a obtuse angle. Okay, it's a obtuse angle. Okay children, now by applying the obtuse angle theorem, what you come to know? That is AB square is equal to BM square, okay, plus AM square. I'll write down here BM square plus AM square plus twice BM into DM. Now this is equation 2. Now by adding equation 1 and 2, okay, by adding equation 1 and equation 2, see what we'll get. That is, see, equation 1 is here, AC square plus AB square, but we'll write it in a correct form. That is AB square plus AC square is equal to CM square plus AM square minus 2CM into DM plus BM square plus AM square plus 2BM into DM. Okay, now children, in given, what they have given, BM is equal to CM. Okay, BM is equal, now you can see this 2BM and 2CM. Now instead of CM, I can write here BM. So what is going to happen? This CM and this BM will get cancelled. You can write down here in bracket CM is equal to BM from given. Okay. Now your equation will be AB square plus AC square is equal to CM square plus AM square. Okay. It will be, now here children, as 2 cm we can write here bm. So this 2 cm into dm will get cancelled, and here also 2 cm, as in place of bm we have written cm, this will get cancelled. So your equation again it will be cm square plus am square, now this is cancelled, plus bm square plus am square. Okay, now children, you can write down here ab square plus ac square is equal to, now this am plus am is 2am square. Now plus, now instead of this cm, I can write down here bm, as you know very well that, I'll mark it with red pen, as cm is equal to bm. Okay, as cm is equal to bm, instead of this cm I'll write down here bm square plus this bm square. That means ab square plus ac square is equal to twice am square plus twice bm square. Okay, it's very easy, just you have to replace the value of cm and bm. Okay children, you have to place the value of cm and bm. Okay, as cm is equal to bm, instead of cm you have to put there bm, and you will get the desired result. So this was the Apollonius theorem. Now in the next session we shall study practice set 2.2.